Well, hello everyone. So I hope that you can see me and that you can hear me. Eleni said already about what we want to do now, and please keep asking questions if anything comes up, and we will try to answer them later. So there are a few questions that we thought of that might be interesting, even for us, but also for you. So one question, for example, that Alvaro was already asked, so he already answered that, is what actually drives us here as astronomers to do what we do, and why did we choose this path? And I think everyone might have like a bit different answer to that. So yeah, for example, Eleni, why don't you start us off? How was that for you?
Oh, okay. Yes, I also wanted to be an archaeologist. It's true. It's true. But I think I agree with most of the things that Alvaro said. We have similar experiences also in Greece. The night sky is gorgeous, especially in the summer. And you fall in love with it, looking at the stars. You are in a beach, there is no light, and you want to learn more about the universe. So every kid wants to become an astronomer. And then during your childhood, you change because you get a lot of influences from other things. And at that time, there was not so much influence in astronomy. So I want to become an archaeologist. I want to become a lawyer, which would make me more money for sure. But
That's also good.
yeah, but then I saw a movie, and this is a true story, guys. And you hear it first. Okay, I watched the movie where one of the actors, the leading actors, it was an actress and she was an astrophysicist. It was an action movie, Chain Reaction with Keanu Reeves. And it inspired me, and I started my direction towards physics. And once you start taking that direction, astrophysics wins. It's my personal experience.
So astrophysics and action can combine to make
Absolutely.
something good. Yeah, there's more than research maybe to astronomers. Um, all right. Kevin, do you want to say something, for example? Do you have any specific
Yeah,
stories?
sure. I don't really have the typical story because as a kid, I never really looked up at the sky. And I just, it was upon just waking up to things in life and having a growing awareness in high school that I began thinking about how did things really work. And fortunately for me, there was an astronomy class offered in high school. And it wasn't very common actually in most schools in the US. But there was this one teacher, Mr. Gyra, who really just influenced everybody, and he does everything around the school, but he's also a biology, physics, astronomy teacher, and had been in this, had started this class for 20 years by the time that I had met him. And then he let me go to a field trip sort of event at Harvard Smithsonian, and that was a year before I could even take the class officially. And I just joined the students and was really inspired. And then after that, I took the class the year after and really enjoyed what I learned. And I realized at some point that there was one memory that I can recall. We looked at the Hubble Ultra Deep Field, which is a classic image of pointing Hubble to a very specific point in the sky and just letting Hubble expose that light for a long time. And what it revealed was that every single point was a galaxy. So my question was, is that, for instance, a picture of us? Is that a picture of the Milky Way just in the past? And my teacher couldn't really precisely answer that in the moment, and I just felt like there was so much to be learned in general. So I just decided to commit to this path. And then when the math got difficult, of course, you have to really commit. I also like to travel a lot, and this was a nice opportunity to do so.
But it's good that you endured all the math to be where you are now and do some really nice research. Okay, Maude, how's it been for you?
Yes, so for me it was also when I was quite young, around 15 I think. I was reading those science magazines for children or teenager, I would say, where there is like all sorts of science, biology, everything. They feature each month like something on a different scientific topic. And one of the first book I read like that, of the first magazine, they had an astrophysics category where they were speaking about gravitational waves. And at that time, it wasn't observed yet. It was still a theory. But I read it, and they were explaining the way like objects that are massive, that are dense, deform space-time. And I thought that was beautiful, the way you could explain something that is so far away in a way I would have never imagined. And at that time, I didn't even know that was general relativity or anything like that. And I just thought, wow, that's amazing. I continue reading those magazines, and especially the astronomy part. And I've discovered about all those incredible events that occur in astronomy, some of the most violent events in our universe, and some of the most powerful. And I found that was just mind-blowing, and being able to explain them, to try to understand them, to study them, I find that really interesting. And I feel like because astronomy study those extreme events, it's really like we are at the border of human knowledge, and that's something I find really, really interesting and fascinating about it. So, yeah, that's why I choose to do that in the end.
That's a good way to think about it, where right, extending a bit the border of human knowledge while we are doing research. So, Sven, how have you come to astronomy?
Yeah, my way was also a bit different. Well, I did look at the stars as a kid, and I did actually also own a very little telescope, but I didn't really plan to be an astronomer at that time. I studied math after school, and then in the end of my studies, I thought about what I want to be when I grew up, and I applied to a young graduate trainee program at ESA. But they didn't accept me, and I talked to one ESA employee, and they said, math isn't really an essential skill for ESA. But I kind of had my head set on, I want to work at ESA. So I thought, what would be a good thing? So I thought, astrophysics might be nice, but now I like it so much that I don't want to go back to ESA. So, that's basically my story.
That's amazing.
Yes, so I'm glad that you liked it that much.
Me too.
How about you, Laila?
Yeah, so I was different. I always wanted to do astronomy and learn about the stars and the universe. And it's not because I looked at the stars as a child, because I come from Ludwigshafen. Those of you in Germany might know it as not being the most, pretty city, and you cannot really see the stars from the ground. But there is a planetarium there, or near there in Mannheim, and my parents always went there with me as a child, and I loved it so much because they would tell you what the stars are called, and they would tell you the stories of the different constellations and all the Greek myths that go with it, and I was so fascinated by them. And then they also showed all those beautiful pictures of galaxies, and I always wanted to understand what they are, where they come from, and how you get all those pretty pictures. So I asked the people at the planetarium, I asked my parents, and after a while my parents couldn't really answer anymore, and the answer was, yeah, you need to study physics to understand that. So yeah, I studied physics in school, I did a lot of math in school, and I ended up actually being an astronomer. And unfortunately, being an astronomer doesn't mean that you get to look at all the pretty pictures all the time. Most of the time you're looking at a computer screen and you're writing code, or hoping that your code works. But in the end, you actually get to understand what those pictures mean, and I think that's even more meaningful. So I'm really glad that I, went this path and actually do astronomy right now.
So your parents and your thirst for knowledge brought you here, basically.
Yeah, my curiosity and the fact that I cannot stop asking questions.
That's probably the case for many of us. So actually for me was also maybe not this romantic look at the night sky, because I am actually from this area, from Bonn, and also the night sky is not as nicely visible as maybe somewhere else. But for example, I remember that I was visiting the Effelsberg telescope when I was a child. So that was because it was quite close, and I already developed an interest in astronomy and like reading a lot of books about it, basically already knowing what I would be at some point. And so far it worked. But this visit also really amazed me, because this really large telescope. I mean, it's 100 meter in diameter, and basically it's one of the, I'm not sure, maybe at that point it was still the largest steerable radio telescope. It was before the Green Bank telescope, which is slightly bigger in the US, was built. And yeah, that really amazed me, and it's nice that I can nowadays work with exactly this data taken at this telescope. All right. So now you maybe know the team a bit better, and what drives us during each day going to work, or at this time stay at home and do our work. Maybe I have a few more things that might be interesting. So, for example, our favorite discoveries that were made in astronomy. I mean, astronomy is quite old, so there are a lot of things which were already discovered, which does not mean that there are not many things still to discover. But we want to talk about what are our favorite discoveries. So
I can start that one off. I think that the cosmic microwave background in 1965 was one of the biggest discoveries, because, well, from that we based everything that we know now, because we realized that we're in a cosmic oven that right now is at 3 Kelvin in temperature, 100 times less than room temperature. But at some point, based on our knowledge from other things, we know that there was this background temperature that wasn't 3 Kelvin, that was millions of Kelvin, and it goes back to the Big Bang. And then if you look at the microwave background, there's so much that you can pick out from just the single universe that we're given. This is the observable universe in our furthest point. But the discovery in and of itself is my favorite because of how it was discovered. They thought that it was a nice story. They had, just trying to remove this excess antenna radiation, even tried to scrape off bird shit, and just like they couldn't remove this background, and that's because it's a cosmic background in the microwave nowadays wavelengths.
Yeah, that's a really nice discovery, and also a nice story that they want to get rid of it, but couldn't, because you can't fool nature. It will still be there. That's really a pretty big discovery. And everyone else has something specific in mind that maybe changed the course of astronomy, or maybe even history.
I don't know if it changed the course of history, probably not, but my favorite discovery is definitely more recent. It's the discovery of gravitational waves, because it's basically the first time that we're observing something that is not photons. And it's like a whole new area of astronomy, basically, which with almost endless possibilities. And also I'm super amazed by how they managed to do that they somehow measure this shift that is, I don't know, 1/40th of a diameter of a proton or something like that. I don't know the exact numbers, but they measure incredibly small changes in distance over several kilometers, and it's just amazing how they did that.
Yes, it's fascinating. and it also links to finding gold in universe.
Right.
That's my favorite discovery, as I mentioned before, from the collision of two neutron stars. So when they collide, they, of course, produce gravitational waves during their dance. So they dance around each other, and the faster they go, the faster the gravitational wave that travels and changes time-space, and it changes also the dimensions of time-space. It stretches it, it pushes it, and this is what it does to the Earth. And with these amazing interferometers, LIGO and Virgo, they managed to detect that. As Sven said, this is in such a big detail, such a small difference, and they managed to detect it. It took 100 years from when the general relativity, the theory, was proposed, to actually detect gravitational waves from an astrophysical source, and it's fascinating. And of course, gold.
Let's try not to exploit all that gold in the universe.
The one that can make space travel, possible fast, like in Star Trek kind of thing, or Star Wars, maybe they will explore it. It's inevitable.
That's what would drive space travel.
There's an infamous non-discovery where they thought that gold was in large quantities in the ocean, and they actually sent large teams to go and just take water from the ocean, and they thought that they would get rich, but it turns out there's such a small little fraction of gold in the ocean that it never worked out.
Well, they made some error with like a few orders of magnitude, I think, when they estimated the gold in the ocean. Yeah, that was pretty funny. Sorry, and not even astronomy related. I was actually thinking of the discovery. Well, it's maybe not one big thing, but I think in the 1920s, Edwin Hubble was like the main person behind, but there were also other persons, leading to the fact that we know now that the whole galaxy is not only it's not the only one, and that things that we observe on the sky are actually outside of our galaxy and much farther away than what we initially thought before that. And it's really how to put it. And we also know that the universe expanded. That probably goes into like the bigger picture that Kevin was also mentioning with the cosmic microwave background, right? That was the first time that we maybe started thinking about, okay, what now that the universe became so big and it's expanding, like what is happening here? And then we slowly build up over decades the picture that we're having now. So, and I think that's sort of a bit of the starting point for me. So I think that's a pretty big deal.
For me, I would say, so if I can join also the discussion, so I would go to much earlier. So since I like all this history and so on, so it's probably not one of the most important discoveries in humanity, but one that marked me a lot when I was younger. So it's 200 more or less before our time, when Eratosthenes was measuring the diameter of the Earth, and he was measuring the shadows that were produced in two cities in Egypt, Aswan and Alexandria. And just by knowing the distance between these two cities and the difference in the shadows, he got to know the diameter of the Earth with a precision of about 10%, which is pretty good at that time. And I remember when I was younger thinking, how was he measuring the distance between the 2 points? Because you cannot put a long meter to measure the distance between two cities. Also, how was he communicating with someone? Because there were no phones. So how to tell someone, measure now the shadow, and I measure the shadow now, to see how that they are measured at the same time. So I remember thinking that at that time there were lots of difficulties to do science, and the kind of discoveries or findings that they found were really impressive. So I think to me, this would be my discovery, but of course did not change that much science as we know it nowadays.
Well, there was a sort of science took a break in between a bit, not entirely, right? But that it did some. They did pretty well, at that
there were
time.
some
It's really impressive.
dark ages in between, right? So since that time till now, something happened, and then now it has exploded, and it's much faster.
And let's hope it
Yes.
will not go back to dark ages.
Okay, so now that we already talked a bit about the past, let's do like a thought experiment where time travel is possible. And if you could talk to or meet any person in the history, probably let's say a scientist, even like if they're dead now, let's say time travel is possible, so you could go back in time and meet them. Who would you meet, and like maybe what would you talk to them about? So, has
So
anyone
I
thought
would-
about that?
Can I jump in?
Of course.
Because I just in connection to our discussion right now about the ancient Greeks, the scientists that I would like to talk to are exactly those scientists from ancient times that we don't know, we don't really know anymore about, because maybe what they've written got lost, maybe what they've done did not seem remarkable for other people, and therefore we don't know about them anymore. And I would really be curious at what kind of knowledge they had, what kind of knowledge has been lost. Maybe knowledge has been found again, but in the end I would be so curious to see what those people that we don't know about really have to say.
I fully agree with that. So how they were thinking. So I was thinking now a name of one of these philosophers, let's say, that it's Aristarchus, that he was essentially the first one, or one of the first ones, who proposed heliocentrism, so that the sun was at the center and not the earth was at the center. And somehow this idea was not maintained over time, or not really supported, because there were no evidences until Copernicus, so like 1500 years later. But I would like to talk to these people to see how they were thinking and how some of them reached these conclusions. So what was the way they were connecting all the impressions that they had from nature? So that would be a good time for me to go to travel.
Yeah, for me too, would be something from ancient times, a bit later than Aristarchus, who was from Samos. Aristarchus or Samios, we say in Greece. So he was.
I like your pronunciation much better than mine. So.
Thank you. It's always Greek all my life, but he was like 300 before Christ. Okay, astronomer, mathematician. But I would go a bit after Christ and go and find Hypatia, who lived in Alexandria, who was born and died in Alexandria of Egypt. And she was a philosopher, astronomer, and mathematician. She was the first female mathematician. She recorded and wrote text, and some of it is we still have it today. Of course, most of the things are lost, as Laila said. So it would be very nice to talk to these people, understand how they thought about nature, and how, because they would combine many sciences, philosophy, mathematics, physics, and today we don't do that. We split them. So at that time, they would combine many sciences and to understand better nature around us. And specific for Hypatia, I would. It's very interesting for me to talk to her, because she was murdered because of her beliefs, because of different religions. So I wanted to understand her way of thinking, and it's like a social experiment in my brain, not only to understand how she thought as a scientist, but what was different for her and the people that murdered her because of different religious beliefs.
So more difficult times. So I'm glad that we are free to do research now, but it would be interesting to see how that actually was for the people back then. All right. Does someone else has like a specific scientist they
Just
want to meet?
a very quick one. Richard Feynman played the bongos, and I play the
I see.
bongos. So and random other drums. So it would be cool, not even just to have a conversation, but to just have a musical conversation with Richard Feynman.
And play
Yeah.
the drums with him.
Yeah, if I can also jump in very quickly, if I could meet someone, I would love to meet Maxwell, James Clerk Maxwell, I think, for a very simple reason. I love the equation, the formalism, Maxwell equation, and everything that you apply to electromagnetism, field mechanics. I think it's one of the most beautiful formalism in physics and mathematics, and you can also generalize it to relativity and so on. And I just find that amazing. So yeah, I would meet him and just say, wow, how did you do that? That's incredible. That's beautiful. Yeah, just to congratulate him, basically.
I think if I may jump in also, I would take a slightly different approach. I would probably visit scientists like Boltzmann, who had a theory that was not accepted by the scientific community, and he actually killed himself 1 year before his theory was proven correct. So I could maybe tell him, hang in one more year, like something like that. And
That's
yeah,
a really good thought. Yeah. So who knows what he might have done if he was to be alive longer, right?
Same with Einstein. Like in 1 year, he revolutionized 2 fields of physics, and then for 10 years, he tried to disprove quantum mechanics. So if he had worked those 10 years on something else.
So take him off this obsession, eh? Yeah.
Exactly.
I think he was a really interesting person. I would actually like to meet him. Then I think actually he's also the one who's assigned the most false quotes. So I could have asked him what he actually said and what he didn't.
But only if he can actually remember.
If he can remember, yes, that's true. But probably at that time everything was. I assume he did so. I think he was also a very interesting and peculiar personality, aside from science. And maybe he could explain GR to me in some way that I don't understand. That would be a really nice thing. All right, let's go back to the present. And presently we are, like you can see, all sitting at home, not only for our live video podcast, but also because we're working from home. So if you wonder how that home office and the current situation around the COVID-19 crisis affects us, we want to talk about that a bit. For example, Álvaro, how is that for you?
So I could say that, so it's a bit annoying that you have to stay home, but since I'm an observer, so I'm used to stay in remote places alone and interacting with people. But yeah, so regarding work, since most of the things that we are doing are with the computer, somehow it's okay-ish, because I can do the same things here to those that I was doing in the office, with the difference that my internet connection is not so great, so then the speed can be a bit slower. And then, so luckily nowadays, I think we have many tools to communicate with people that are distant. And then we can continue having these meetings that I was mentioning in the beginning, that it's where we trigger discussions or we have ideas of what to do next. So we can continue having them. So I'm quite happy about this. But of course, so what it's missing is more this social interaction. Sometimes just drinking a coffee, you have lots of ideas, and now you cannot have it, right?
Yes.
Unless you have virtual coffee. So at 11 o'clock, you Zoom with your with your colleagues, and you have a coffee for like 10-15 minutes, and ideas come through.
Yes, this casual coffee with colleagues in the kitchen area, that's what I really miss too.
How are you feeling this situation? Because maybe for you guys, most of you are PhD students, so do you see it really different, or working from home compared to working from the office?
Well, normally my supervisor is more or less next doors. So in case he's not on traveling or so, I can always like see him, and if he's not too busy, and ask him something that's on my mind, or just asking any colleague for if I have a question, like, or how do you use that software that I have never used, or maybe you have a scientific question that you won't have answered. Like that's a bit more difficult to do. Like, you just don't call the people like that when you're compared to when you just casually walk to their offices. Yeah, that's I don't know how's it for the other people who are students. I think the contact to my supervisor is a bit less. I'm still contacting him by Zoom meetings or so, but it's of course not as frequent as it could be if we weren't to stay home.
Yeah, also a supervisor can better like ignore you. I don't mean it in a bad way, but sometimes when you want to really to talk to your supervisor, and it has to be right now, sometimes you can just catch them in their office and go to their office. But you know, if they're not in their offices and you need to write them an email to actually contact them, then it's easier for them to say, okay, I don't have any time today, I have stuff to do. So I feel like I'm also having less contact with my supervisor right now. But on the other hand, I think we're all pretty fortunate in that we can actually work from home, because I can do all my work remotely. And I don't know how it is with you guys, if you really need stuff that is in the institute or the computers in the institute, but I think we can all access them pretty well remotely. So we're quite fortunate in that respect, I think, compared to other people working other jobs where they really cannot work from home.
Yes, that is a problem indeed. And supervisors also usually are older, so they have other responsibilities like families, homeschooling, which is now a big problem because most of the schools have dropped all the educational ways on the parents. So just loads of homework and that's it. The kid has to do it. So imagine your supervisor trying to balance the situation very fast. So it's for everyone is a time of adaptation. You know, we try to adapt to new situations. As you said, we are the ones that are more accustomed to it because of our way of work. We are used to working alone. We are used to working in our personal laptops at home. We can access our work computers. There is this possibility. We can talk to our colleagues via Zoom, via Skype, but astronomy is not only that, is the connection that we are missing. This is why we meet in conferences, because of the social interaction that somehow improves brainstorming. I don't know how it does it, but it happens. It improves collaborations, because collaborations are not only these Zoom meetings. You spend time with other person, you have dinner, you have a casual discussion, you talk about science also, and it's more casual, and you can form a better collaboration than when you do it virtually. I totally believe that, and I think this is going to have a very big impact on astronomy. I hope it's for a short time. And because people try to balance too many things at the same time, there is not much time anymore. If you don't have a family and you're alone at home, there is a lot of time, but still you might not be productive because there is a lot to comprehend. So that's a big problem. It's also an emotional, a psychological problem. And on the other hand, if you have too many things to balance, it's also an emotional problem because you don't have enough time, you don't know where to give more weight. So I think we're all trying to do the best under very difficult circumstances. And first of all, we should take care of our mental health, talk to our friends, to our family, and try to take care of ourselves more. And there are a lot of help videos available to help us go through this difficult situation through approved techniques from psychologists, not random YouTube videos. So if you need links, I can happily provide from trained psychologists.
You can start becoming friends and talking to your spiders.
Is this what you do? I don't have spiders, I clean.
A couple times a week, talk to them.
They're useful to get rid of mosquitoes or flies. I keep them as pet.
But this offers an opportunity to stop and breathe. And at least for me, I've been traveling a lot throughout my PhD, and fortunately, I didn't have any travels planned that I had booked or anything, so I lucked out in that sense. But I've just been reflecting a lot and taking this time to kind of start from scratch on some level in many different areas of my work.
Yes. I mean, I think you actually have a lot of time to think. And you should probably also take that time to do that, and maybe consider, like Eleni said, consider your mental health.
And
is that teaching is, at least for us students, it's good that teaching at the university has been suspended for a couple of weeks. So this also gives some extra time.
That's good.
Yeah, I think it's still unclear how it's going to start at the end of April, but I feel like it's really good there's no teaching right now.
You can use this time also to watch Astronomy on Tap Bonn videos from past events, which talk to you about the universe in a very simple way. So it's very good time. Not only Netflix, there is also Astronomy on Tap Bonn. So subscribe.
You can find all, I think more or less all the talks so far there. So there have been a lot.
Yes, we are on season 2, right? So towards the end of season 2. So a lot of videos to watch, different subjects, very interesting. So maybe that's a solution for the mental health, taking care of your mental health. Watch Astronomy on Tap videos.
That's a really good suggestion for all viewers. But let's just hope that everything will be cleared up as soon as possible and that we be able to move on. Let's talk about something maybe a bit related about academia in general, how we work and live in it, and how the working environment is in general. I think now we see that some things are generally good. If we, for example, can work from home. But more in general, what do you think about working in academia? Do you like it? Is there something that could be improved?
I think that there's a disconnect with our lives as human beings and us being viewed as statistics and number crunchers and just simply doing science just to follow rules and develop and do research, but not really thinking outside of the box of how that impacts other lives, or how that impacts our own lives and those around us, and how we can use our understanding of our own life and those around us to then influence and inspire our own science. And so I think working in academia right now is really there's a lot growing in terms of technology. There's a lot growing in terms of interdisciplinary sciences. But if you think of what Álvaro had said in terms of theory and observations, there's always this more practical aspect, hands-on experimental observation side of things. and then there's this theory that develops the motivation to do the observations. And I think that we, although theory is intangible, still give as much credit to the theory as we do to tangible observational science. And in a similar sense, we don't give much credit to the intangible aspects of our emotional or mental or spiritual aspects which influence our science, and we think of it as not on the same pedestal. So on some sense, it's more abstract. It's, telling me how to live my life. It's, what does intuition have to do with writing this code? Things like this. And I think the attitude is starting to shift, but that is one of the challenges working in academia as we start to evolve as human beings doing science in only 200 years after science really kicked off. So we're realizing that our human life itself and how we view it in relation to the science that we do is just as important as the output of the science. But that's a challenge right now, I believe, right, that's at the forefront.
Yeah, I think that's true, and I mean, we all told our stories about like how we came into astronomy, but like keeping up like this very early fascination for a very long time. I think it's not it's not always there necessarily. Sometimes you might sit in front of your code for days or weeks, and you're like losing the connection to what that actually does for you in terms of science, and like what you originally thought, what you wanted to explore. So having this connection that also leads like to the interconnection between theory and observations that was mentioned. I think yes, that's very important. And I don't want to say too much about Astronomy at Tab Bonn, but I think what we do here is especially important, also for us. I hope that you also enjoyed as viewers, but for us it's also important to also see for ourselves the bigger picture that we are in.
Yeah, I think that's a really good point. Often we are just so concentrated on our own little piece of work, which is just a subtopic of a subtopic of a subtopic maybe. Then I really think it's for me also fascinating to watch all the talks by people working on something completely different than what I'm doing, and I really enjoy that. And I think we all need to sometimes be reminded of all the other parts of astronomy that are just as fascinating as the things that we are working on right now.
Yeah, I totally agree. And one of those advantages of having all those talks, all those group meetings and conferences is really like learning something new. I think for all of us, we will agree on the fact that pretty much every day we learn something new. And I think we are really fortunate for that, because there is probably not a lot of work where you can basically, you're being paid to learn and understand and spend time on getting really deep into a subject. And that's something I really like about working in academia. Yeah.
I think it also kind of speaks for our society that we are able to do it, because what we're doing, to be honest, has no value for the everyday life. It's just because we want to know it, because
I disagree.
It's something. Okay.
But I will tell you later.
Okay, let me rephrase. Has no practical value for everyday life.
I disagree.
Yes.
I have examples.
Yeah, okay. There might be some counterexamples, but I can confidently tell you that what I'm doing will have no impact on anyone's life that is not working in astronomy.
Not yet. Maybe in the future.
Maybe. But the thing that we are able to research things because we think they're interesting and because we want to know them, I think speaks also for us as a society. Because I think that's also how we grow, basically.
Sorry for interrupting you. It was very.
No, it's fine. I know you have.
I'm very passionate
some
about this
counterexamples.
specific topic. I'm sorry I interrupted you. That was extremely rude.
No
It's my
worries.
passion for this topic because it's a common misunderstanding, even of astronomers, that astronomy does not give anything back and it's not useful to everyday life. We're changing subject, but it's important because the applications of astronomy and what has been developed so far improve our everyday lives. I will give you an example. For dinner, I cooked on a ceramic kitchen. The material, ceran, was created for as a substrate for space telescopes by a German company, Scott, in the 1970s. So space telescopes, the mirror does not change, the surface of the mirror does not change from the differences of temperature from, when it looks at the sun and when it looks away. So we can take good observations. But this material was so good that they used it to make kitchens, and now we cook on them. Wi-Fi was created by astronomers in Australia. Okay, and now we're using it to broadcast this live and talk about astronomy. And so many other applications, and there are articles about this at the International Astronomical Union website. I've also written articles on that. So astronomy does bring things back to society. And I think people should stop saying that astronomy is just a science, that, why do we do it? Why should we give money to astronomy if it doesn't benefit us? Medicine is very important, and we have seen how important it is during this pandemic. But through the developments of astronomy, we have CAT scans, sorry. We have CAT scans, we have codes that were used in radio astronomy that are applied for medicine, and so many other applications that could not have happened if an astronomer didn't want to understand why this star is brighter than the other star, for example.
But this argument doesn't really apply to everyone working on the theory side.
Yeah,
Not everything that you do in theory will have an application, but we do it regardless because we want to understand.
But it's a link. If you don't write the theory, then we cannot do the observations and compare them. And what Álvaro, if you want to jump in, what Álvaro was saying before, that he's comparing observation and theory. If you don't have the theory and if you don't develop the same things together, it will not happen. And you need the theoretical part too. For example, Wi-Fi, how to write all the equations for that and the path.
Okay, then let me just say that it's not our intention to do these things. These are more byproducts of what we do. I don't try to do something that will better the lives of people. I try to understand the matter content of the universe, basically. And there might be something as a byproduct that also contributes to society, but it's not my goal, basically. That's more what I meant. Maybe I phrased that wrong.
I just want to do a very quick comment. Theory do sometimes bring something very practical to people. It's not often. It's of course not the main objective first, but one of the very famous application of special relativity is GPS. We will not have any GPS without special relativity, and that's hardcore theory right there. Yes, sometimes it does happen, but I do agree with you. It's not all the theory, and it's a byproduct. That's absolutely true, yes.
I think in conclusion, we could say that more money should be spent on astronomy.
Exactly.
Yes. Yes.
Give us money.
We all agree about that. We all find hopefully astronomy very exciting. So in the end, you will pay us somehow via tax money that you pay, which pays us.
If I can also add to what Maude said about the GPS, it's not only the equations and the theory behind it, it's also the applications. So radio telescopes, the VLBI network, help me, how does it spell out, Felix, the VLBI? Very long baseline interferometry, right?
Correct.
Yes, thank you very much. So it's this network that helps GPS stay there, and we can keep track of our movements. Okay.
Yeah.
Do we have more questions?
I think we had some more questions, but it's taking quite a long time now, right? So maybe we should.
Let's do the last one. That is exciting.
All right. We talked about earlier about some discoveries that we thought were very interesting, but of course there will be some future discoveries. And the question, what do you think is like the next big discovery? There are many things to be discovered, but what could be the next big thing?
I think maybe the modified gravity, the fact that gravity might change with time, might be the next biggest discovery. But I think it'll be such a discovery where it can't obviously change our understanding from how we know it now, because so many tests have been verified. But on some level, it might help resolve some discrepancies, but fill in some blanks.
I'd say the thing that I find the most exciting, and that would be space travel. I really want to have space travel.
Yes.
I want people to go to Mars and beyond.
Yeah, you wrote that article about space sailing ships, right? That was really interesting.
Yes, so there are some people working on ways to actually have interstellar travel, which is quite difficult to have with a usual rocket, because you need a lot of fuel, and if you have a lot of fuel, then the rocket will get really heavy and you need even more fuel to accelerate it. So the idea is that you have actually a sail. So the sail will then be propelled by photons, so from light, and this will propel the ship forward, and you can actually get really fast and have interstellar travel. So that would be really exciting if that would work.
I can do that. I won't do that. Yes, that's the best.
Also, there's this old project Orion that was researched by NASA at some point, where it's basically you build a giant spaceship and set off nukes behind it. And that would be a win-win, in my opinion, because we would get rid of all the nukes. I mean, we can destroy our planet like 40 times over. Why do we need that? And we would have interstellar travel, so...
That's fantastic.
I don't want to be on that spaceship, though.
It'll definitely lighten up the sky for a few weeks.
Yeah.
I don't think we will survive.
Yeah, better like get far away first, and then start with the nuking.
Yeah. I mean, I haven't really researched it, but apparently they have developed some kind of shielding that would actually like make it possible to live on the ship, but I don't know too much about that.
Yeah, if I can jump in very quickly, I personally think one of the big discovery that will happen in the future would be to clarify what is dark energy, because that's the main component of our universe, 70%, and that could be one of the explanation of what the universe is in accelerated expansion. So that would be really game-changing, I guess. And the second big thing would be dark matter, which is the second biggest component. And those two things are totally unknown and not very well understood. So I think that could be a very big discovery also, yes.
Yes, definitely. We've been in the dark about the dark energy, pun intended, for a long time now. So it would be really great to have that resolved at some point.
How about life?
Yeah, exactly. So I think we had some inspiration from the live chat that said a great discovery would be alien life. Exactly, that would be a really great discovery. I don't know, like how exactly we'll find life. I mean, it could be that we find some life forms on Mars, some hidden underground seas or something like that, where we find some bacteria or so. It could be like something that that's simple, or we could be overrun by some alien civilization tomorrow. Like there are very, very much different scales on how we could discover them or encounter them. I think that the most probable thing would probably be like finding life on Mars or in some asteroid or so.
To this point, so we could think, what is life? Right. So we don't have a good definition of life. So I was reading some books last semester, just preparing some lectures, and I like what the author of that book presented, because he was saying we're in an epoch that we are trying to define what is life without having all the tools to understand what is life. And he was saying, imagine that you go to the 1500s, so when Galileo or so, and you ask any of those persons, what is water? So now we know that water is H2O, because we know that there are atoms of hydrogen and oxygen. But at that time, they could not define water like this. So maybe we are in a stage in which, so maybe we have already found life somewhere else, but we cannot recognize it because it's not the life that we understand. So I think we need to understand what is life first.
It could be also like, is there something that are very similar to our definition of life, but not quite? Take the coronavirus that we're having now, for example. I mean, they're not exactly life forms, but it's also hard to say they are really not, right? Because they have RNA. They many of the things that we like would say are very much lifelike. Are the case for viruses, but there are some other things that where they don't fall into that definition, but they're not life. But if we would discover some virus on Mars, that would be a pretty big thing, right? So then would we say we didn't discover life? Yeah, it's, maybe we will also change our definition of that based on what we find.
But I think also we're looking for intelligent life in the sense that they can produce telecommunications. And that's why the SETI project is looking at the radio frequencies to see if there are any signals coming from space that might be made in the same way we make signals through our radios, televisions, all this electronics. But maybe in the future we will be able to detect something like that. This has not happened as yet.
Yes. So that would be a really great thing. Maybe we can like make some connections with some exoplanet that we find at some point, which we think might harbor life. There could be a connection there, and I think the exoplanet science is really exploding. So I think we will find a lot more of them in the future.
For me also would be a very nice, sorry if I talk a lot, but for me it would be very exciting to be able to detect the gravitational waves from when the universe was created. So before the cosmic microwave background radiation. So there is a point in time before that we cannot observe with our telescopes because there was no light. We cannot see it with our current telescopes. So one of the methods to understand what was happening before is to detect gravitational waves that came from the Big Bang. The current theory, we believe, how the universe was created. So for me, that would be very exciting. And maybe someone on the theoretical part can comment more on that. Maybe Laila?
Are the current interferometers like LIGO or so, are they? I think they're not capable of observing that, right? I don't know if it would be possible with this LISA, which is like the space laser interferometer for detecting gravitational waves. I don't know if that maybe will be able to detect.
I don't know if it has the capability. So at the moment, LIGO and the two LIGO and Virgo can detect collisions, gravitational waves from collisions, supermassive black holes and neutron stars of small masses, solar masses, 20 solar masses, around that range, up to 80, I think, 20, 40 solar masses. But then LISA will be able to detect gravitational waves from collision of supermassive black holes, which so these are in the center of galaxies. But I'm not aware for gravitational waves from the beginning of the universe.
I think it's also a frequency problem, because basically you cannot detect waves that are outside a certain frequency range. And as far as I know, a very good hope to also detect these gravitational waves are these pulsar timing arrays, where you observe pulsars that are like really, really precise clocks. And from the time between the pulses, you can sometimes also try to detect gravitational waves. But as far as I know, I'm really not an expert in this. This is like all in baby shoes still, and like still being developed.
I'm not an expert on it either, but I think the gravitational waves that you have from the Big Bang, they have really, really long wavelengths. So with pulsar timing, you could detect them, because they can basically detect really low frequency gravitational waves, so also those that have really long wavelengths. But if you want to detect them with a gravitational wave detector, you would need a really large detector, so that's why LIGO cannot do that. I'm not sure if LISA, so the one in space, would be able to detect it, but I doubt it, actually.
I think it's not the main purpose that it's built for. But I mean, we can hope for the future that will be able to build an instrument. Maybe there will be some instrument that we cannot think of right now that will be able to do it, right? That would definitely be very nice to go to the very, very early days of our universe, the dark ages. That's how we call them. All right. Does anyone else have like a discovery that they want to talk about, which might happen? I mean,
just to conclude, sorry. So probably something that will happen really soon is standardization of quantum computation, and this can speed up all the processing, and then this can make it possible all these discoveries that we were talking till now. So maybe quantum computers is the future to the future.
That could improve, like, basically on any level and any other science, right? So yes, it would be groundbreaking.
That is very important, because the next generation telescopes observe a lot of information, and this needs to be stored and processed. So current computers, even supercomputers that we're using for very complicated calculations, cannot do that. So we need quantum computers to process all this information and help us understand. So we're talking about a lot of big data, bigger than big data. Terabytes of information, for example, the square kilometer array. So I still remember the early times when I was a PhD student in Oxford, and my supervisor, Steve Rawlings, co-wrote the white paper on that. And they were saying that you do need quantum computers to happen in order for full SKA to be possible, because you have terabytes of information every day, even more. And at the moment, what is happening is you're sacrificing that data and deleting it. And of course, you cannot process fast enough all the information you're getting. So I agree with Álvaro 100%.
Yeah, when we think about the image of the black hole in M87, for example, that was taken by the Event Horizon Telescope collaboration. The technology of VLBI, like very long baseline interferometry, that we used to do that, where the telescopes are distributed all over the world, and we connect them basically later via a computer. This technology has been around for like 50 years or so. So we know that it's possible, but it is only that we had the additional technology of better receivers, better computers that could store and process all the data, that we could actually handle these high frequencies and be able to detect that. So technology is definitely a big part there. All right. Let us stop here the discussion. I think it has been very interesting. And I think now we will have another highlight, which will be a slam talk by Sandra. We cannot hear you.
I was
Eleni.
muted. Yes, I understood. Yeah. It's like in dreams, when you think you're speaking, but no one can hear you. This happened in reality.
That's a bad feeling.
It was the worst. So I was trying to see if we have any more questions from the live chat, because we said we will answer the questions from the audience.
Do we have some more questions?
I'm waiting for Laila to respond, because I don't have the live chat in front of me.
Yeah, I can ask you
we had one earlier. If wormholes are possible. Yeah. I don't know the answer to this. If anyone knows.
You mean wormholes made by worms in the ground, or wormholes?
Well, I would answer it from a theory perspective and say, yes, theoretically wormholes are possible, but they would exist for so short a time and would be so unstable that we could not use them as they do in Interstellar. But in principle they're possible, and the universe is infinite, so who knows if they're there, but I doubt it that we will ever find one.
I think Interstellar it has been created by basically by the humans from another time, right? So they knew some technology to do it. I mean, we don't know, right? Maybe sometimes we can influence that, but it would be speaking like of very, very much time in the future.
So fantastic. Thank you, Felix, for moderating this very interesting session with all this debate. I think we learned a lot of things, and it can only generate more questions, for sure. These discussions, it's infinite. It's infinite.